All right, everybody. Today we get to discuss multiple dimensions. Now, I'm not referring to, you know, the multiverse or anything like that. I'm talking about multiple dimensions in arrays. So far we've dealt with a single dimensional array. And effectively what that is just a 2D, well not even a 2D actually, a 1D array. We just have a little box, and inside yet said box, we have a couple of slots, right? Let's do it this way. Boop, boop. Let's make this as simple as possible for everybody to kind of follow. So, this would be a single dimensional array. We've got, in this particular case, 0 and slot 1. Now, whenever I'm referring to this, it would be array 0 would be here, array 1 would be here. Now, if I were to make this a two-dimensional array, I could add another column, basically. And now I would have actually a 0 up here and a 1 here. So this would actually be spot 0, 0. This would be spot 0, 1. This would be spot 0, 1, and this would be, 1, 0 actually. 1. Let's get rid of that so I can fix that. Oop. There we go. So this would be 1, 0. So that would be the locations for each of this. And I can make this, hundreds of rows, columns if I wanted to. A good example of a 2D array would be, let's say, a tile map or something in one of those old school Nintendo or Super Nintendo games, top-down games. They effectively have a giant array with all kinds of little pictures in each little slot. So I could have like, some grass here and then road here, and you just draw basically the entire map inside of an array. That's one way you could do that. The other way would probably be with objects, but you'd still use arrays to some effect. Now, of course, I could also put numbers in here, like so. Or this could be an entire database. I have my columns up here. I have my rows going down. There's numerous ways we can actually work with a two-dimensional array. Now, again, this is a 2D array. 2 dimensions. Going down, going across. Now, this could be a 3-dimensional array if I wanted to make it so, and I kind of envision a Rubik's Cube for that. I would just have one more number. I would have 0, 0, 0, 0, 1, 0. Uh, you'd have another direction you could go. So again, envision basically a Rubik's Cube for that. You kind of have your idea of a 3-dimensional array. Another good example of that would probably be Minecraft. Effectively, it is a giant 3D world of blocks. You can dig down, you can go left, you can go right, you can go up in 3 dimensions. That would be basically a 3-dimensional array. The entire thing is filled randomly kind of as you move around the world. So the way that game works is the world isn't shaped and created before you get to an area. So if I am in an area, it'll populate that area. As I move, it starts populating areas outside of that. That's why the longer you play in a game, the larger the Minecraft game actually gets to be. And this is kind of the same approach that's used in a lot of other places too. Now I could have a 4-dimensional array if you wanted to. I don't think I'd go really beyond that. Normally you don't see much beyond 2. Rarely you'll see 3. Example of a 4-dimensional array, let's say, all right, let's say we have a Minecraft world, right? We save it. That is that world at that particular time point. Maybe an hour later, I've been doing some stuff, I've been building, I save again. That is the world at that particular time point. That would be basically your 4-dimensional array, with the last location being time. Let's see how basically a two-dimensional array differs from a single-dimensional array. Kind of give you a rough idea here. So int, I'll just call it array 1D equals new int, let's say 2, right? And then I would say, array 1D 0 equals 10, and array 1D 1 equals 15 or something. Oh, and just as a side note, I can do this. A lot of people think this is an error, but no. It's basically, this is a variable. I'm assigning it 10. 1 is a variable. I'm assigning it 15. I'm reassigning 22 to this one, so basically the 10 gets replaced by 22. That's a very common mistake people tend to make. So I just mention it here so you guys kind of realize that that's not an error. I'm just basically, after at this point, 0 is 22. The 10 gets replaced. But that's a single dimensional array. If I wanted a two-dimensional array, it would look like this. 2D equals new int, let's say 2, 2. That would be a declaration for a two-dimensional array. And of course I can say 0, 0 equals 1, array 2D 0, 1 equals 2. And I just keep going on, 1, 0 equals 3. And the last spot, 1, 1 equals 4. So if you remember the picture we just saw, that's what I made. Basically right there. This is a 2 by 2. 2 across, 2 down. And if you notice, that's slot 0, 0, that's slot 0, 1, that's slot 1, 0, that's slot 1, 1, right there. So this is effectively what I made. Now if I wanted it to be a 2 by 3, then I'd have another, column over here. If it was a 3 by 2, then I'd have another row. So the first one is basically going down, the second one's going across. Now when we print these, or access them, we have to do it a little differently than your regular single dimensional array. If I want to print a single dimensional array for int I equals 0, I less than array 1d.length I++, and I just simply print array 1d I, right? And that will print the entire array, whether it's a million, whether it's 2, and I'll get those numbers printed. But let's just make a little dotted line here. If I want to print 2D array, I'm just going to copy and paste. What I need actually is, let's move down, 2 for loops. J equals 0. J less than, instead of array 1D, it'll be array 2D. And now the 2D is right here going down. This one here, it should be, well, J is less than array 2D I dot length J++. And brace in 4. Okay. So that took me a moment here. Whoop, it added me an extra. Or I added an extra accidentally. So, now here's the problem. If I were to do this and try to print that, 10, 10, 15, 15, right? It's just going to print that location. Actually, whoops, it needs to be 2D. Let me fix my adjustments here. There we go. Whenever you print an array, if you don't specify the location, if you remember, what you get is this, pointer values of where they are kind of in memory. Now, I have to have a little designation that says specifically where they are. Now with the two-dimensional array, this array 2I is actually just the row location. So if we look back at my handy dandy picture, zoom out so I can get to it. There we go. Array 0, for example, just array 0, is just the location of this. Basically, the way a two-dimensional array works, uh, it is an array of arrays. So I make an array going down, however you want to envision that. And each location has its own little array in it. That's kind of how this two-dimensional array works. So this would be 0 and 1. That would be 0, 1, 0, 1. So that kind of gets you the idea, I hope, of how that kind of functions a little bit. 0, 1, 0, and 1. So this would be 0, 0 because it's in this row and it's this spot. This would be 0, 1. 1, 0, 1, 1. That's basically how it's set up. Now, you could have something called a jagged array where basically one of these particular rows is bigger than the other. They don't have to be the same size. I could actually go through these one at a time. Array 0 equals new int. I could do this, for example. Array 2D, 0 equals new int. And then set its size that way if I wanted to. I'd have to readjust this up here, though. Probably just do something like that, and then I could do it. But you can actually set each size and each column, each row rather, individually in sizes if you wanted to. And then of course it would look pretty close to what you see here. So there we go. All right, so this is what's needed for a two-dimensional array. Now you'll see that I need to specify the J location, and then I should be good. So let's take a look. Now, oh wait, there is one more thing. Well, I'm going to go ahead and print it just so we can see it. 1, 2, 3, 4. Now if I want this to print kind of like it's supposed to look, I can adjust it a little bit. 1, 2, 3, 4. So I can make this a print instead of a print line, and then just add at the end of this inner 4, this 4j, which you can specify a little bit more if you want. I can just put a print line. So basically you can kind of think of this as a typewriter. This inner loop prints going across. 1, 2. And then the outer loop moves me down to the next line, and then I print 1, 0, 1, 0, 1, 0, 1, whatever numbers happen to be in there. In this case, 3, 4. Just like that. So, and you get something that looks a little bit like this. But either way technically works. It just depends on how you want to display it. If you want to display it like this is kind of how you would deal with it. If I wanted to randomly fill it, well, it would be this exact same structure basically. The array's name dot length would get me going down. Array I dot length will get me going across. So this will work no matter if it's jagged or if it's funky shaped. In this case, it is a nice even square, which in most cases it usually is. A chessboard, tic-tac-toe, whatever, will generally be nice and even. Battleship. But it's not always that way. It just depends on what you're trying to build. Now this is 2 dimensions. Now, of course, I could have multiple dimensions. You can actually have, int big 3D array. I could have, more. Forget that. You can actually make these as much as you want. A three-dimensional array would be an array of arrays of arrays. So think of it like this, and then each one of these guys would have an array in it. like that. That's basically how a three-dimensional array is kind of structured. I prefer the Rubik's Cube in my head example, but you can kind of use whatever works for you. Now this would be an array of 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 arrays. There is absolutely no reason to have anything like that. Actually, I don't know that that will necessarily not destroy itself if I made it too big, but that would just be ridiculous. There's no reason to have anything that big. The biggest you'll typically see is a three-dimensional, but two is honestly the most common. One and two are used for 95% of everything. You'll occasionally see three and maybe four. A good example of another four might be Google actually has a big cache of websites that they keep. And if a website's down, you can actually click the cache to copy and pull up the old copy that it copied over. This has gotten some places into some trouble because they posted something they shouldn't have and they immediately had to take it down. But Google cached it, so you could still access it for like weeks after it was actually taken down. I know a few people who've run into that issue. Well, anyway, this is multiple dimensions. It's very useful depending on what you're trying to build. A game board, a map. Uh, if I was overlaying an array over a map, maybe we're doing a search grid for some missing person, and I was just marking the places that have been searched. That would basically just be a two-dimensional array. Databases, all those things would be fair game for two-dimensional arrays. All right, play around with that a little bit. Make a couple of different sizes, different types, not just ints, but strings, characters, doubles, and fill it up and print it out. Maybe even randomly fill it, which the only thing you really have to change here is the name of the array and then put the random number here. But do that, give it a little try, and you'll learn a little bit more about it. If you have any problems or questions, let me know.